How's it going, everybody? I wanted to transition into the localized policies section. Now, this is going to be it's going to fall underneath the policies portion, but because localized policies don't require you to do anything really fancy from a perspective of having a vSmart template that you push from vManage down to the vSmart, you're not doing a centralized control policy. We will take a look at some other aspects of stuff when it comes to the other policy types and capabilities, but right now we're going to be focusing on just localized data policies, meaning that whether we create it on VPN1 and like we did for BGP traffic engineering, where we created a policy and we went underneath policy, we created a route policy, we added a sequence, and then we basically set the action to accept the routes and then set local preference. And then we put tied the route policy name of, I think it was RP BGP routes, and we set it outbound towards the connection towards switch 16. Well, that was great, right? It worked out for us. But when we created that on vManage, we had to create the route policy rule first, then create a policy itself, and then call the route policy from that, and then we were able to push that policy down to the V-edge. Well, we're going to continue that process, but we're going to be looking at it from the perspective of an access control list, or an ACL. So we're going to take a look at a couple of different examples here as we go forward. We're going to look at it from a pseudo, how do I word this? Kind of like a standard ACL, where we look at just the IP packet itself. So there's not a direct correlation that I've found from a standard ACL to an extended ACL, where you would just match on the source traffic, and it's all IP traffic, so TCP, UDP, ICP, whatever the case might be, where we'll take a look at it from just all traffic going to a particular destination will get dropped, for example, and then we're also going to go and say for traffic that is a specific type, we're going to block. So for example, on VPN1, we'll do an inbound ACL, we'll look at it from both inbound and outbound. But for example, with let's say we block the loopback addresses of all of the V-edges or all the iOS routers at the branches. We block all of those, the 13, the 14, and the 15 routes from gaining access to the internet. Right, we'll block that traffic, and then we'll create another access list inbound on VPN1 that will say any traffic from router 5 or router 6 that is going to any of the remote destinations, we're going to block telnet access. So we'll test it out beforehand, make sure it works, but then once it's up and running, we'll go ahead and use an ACL inbound, and we'll test that out. That shouldn't go. That should go pretty quick because it's command line and it's usually pretty snappy. The vManage portion of where we have to create the policies and then push them down to the box to the appropriate V-edges, we're going to look at doing that on V-edge 3 and V-edge 4, and V-edge. We'll do V-edge 5, and what we're going to basically do is we're going to. I'll give you a couple of examples of how that would work, inbound versus outbound and stuff like that, because you have to create go underneath the policy section, go underneath localized. You got to create the access list itself. You got to match on the traffic that you want to block or filter. Then you've got to got to call from an actual policy itself. And then you got to push the policy to the V-edge. And once the policy has been pushed, then you can actually go underneath the templates and then call the policy that was pushed to the V-edge from the template so that it can actually get applied. So there's a lot more legwork on the vManage side than there is, and I'm probably going to break it up just so we can see what that looks like. So we'll do CLI based with that, and then we'll take a look at another variation with vManage where we do it via templates. So that's basically how we're going to go about doing that. So with that being said, now that you know what we're going to try to break down, we're going to go ahead and dive into those aspects. All right, on VPN1, we're going to get out of here. And one of the things that I just did was I re-advertised, or I went ahead and I advertised default routes over I took the default route that we're learning from ASA1 via VEdge1, and I propagated that over to the branch or the spoke V-edges. And if we look at router 13 and I'm learning a default route. So we should have that connectivity up and running now. And if I look back at VEdge1 and I do a show IP route VPN1, we should be learning the loopback addresses of the remote sites, which we are. So that means I should be able to block that traffic as we are going forward and things like that. So I'm learning those routes in, and everything's looking pretty good in terms of the operations and things like that. Why am I learning those? That's a little bit weird. Let me go to switch 16 and let's do a show IP route. How are we learning those routes in? We're learning those in via VEdge2. Okay, so let me go. I don't have that route propagated. I don't have vmanage set up, or I don't have the VEdge2 set up to push a default route by redistributing OMP. But let me go ahead and focus on getting this stuff squared away. So actually what I need to do is, if we were to go to, for example, let's go to router 13, and I should be able to ping 1.2.3.4 sourcing from loopback 0. And you know what? It won't actually. That won't work. That's my mistake. And the reason why it won't work is on the ASA. If we look at the show access list, we're not matching on that traffic. We are. I'm sorry. Show NAT. We're not matching on any of that. So show run object network. We're not matching on that traffic itself. What I can do is I can create an object of network and call this spoke loopback for iOS 13. And what I'm going to do is come in there and I'm going to type in, since it's a /32, I'm going to type in the host of 13.13.13.13 and hit the enter key. And then I'm going to type in NAT and be inside to outside and dynamic interface. Okay, so now if I do the same thing again, that is allowed out. So now it's being natted, and we're all good there. I'm going to do the same thing on ASA1. I'm going to hit the up arrow a couple times and just do 14 and make that a 4. Whoops. And we'll go ahead up here and change the NAT statement over. So if we do a show run NAT, we should have those guys going show run object network. And so that's working the way we want it to. Hit the up arrow one more time, a few more times to get 15 in there. We'll hit the host IP address will be 15. And whoops. There we go. And then we'll hit the up arrow a couple times to get to the NAT object. There we go. So now if I go to 14 and I show IP route, and if I do a ping to 1.2.3.4 sourcing from loopback 0, the ping goes through. 15 should be the same thing. Ping 1.2.3.4 sourcing from loopback 0. Maybe I did not configure that yet. Let's show IP route. Okay, show IP interface brief. So interface loopback 0, IP address of 15.15.15.15/32. And we're going to go ahead and hit the up arrow and try that ping one more time. There it goes. So now what I'm going to do is on VEdge1, I'm going to go underneath here for VPN1. I'm going to apply this to VPN1 gig 0/2, and I just have to make sure that the flow goes the way that I need it to. So if I do a trace route this way, numerically, I need to come in I come in 13, I land on 1, right? I come in on 1, and then I go out towards 16. So my egress point is coming out off of VEdge 1 towards switch 16, and then I'm able to go out to the internet. That's important because if the traffic is not in that data path, then the ACL will have no effect. So you got to make sure that the traffic is actually coming in on VEdge 1. So when we look back at, say, VEdge 3, and we look at where the traffic is going, we got to make sure that the traffic is flowing towards 1, right? And if we look at VEdge 1 and we do a do show IP route VPN1, we need to make sure that we are sending traffic. It's going out gig 2. There we go. That's better. Now they're being learned. Technically speaking, it shouldn't be coming from switch 2. I'm not sure why it's still learning it that direction, even though VEdge 2 is learning. Let's log in here real quick. Show IP route VPN1. So okay. So the way that the routing is set up, it's a little unorthodox, but from a routing perspective, it's being learned. At least as long as the VEdge can get across, it can push the data from 13 to VEdge 3 over to VEdge 1 from a routing perspective, and then switch 16 will push it down to ASA 1. So what I'm going to do is on VEdge 1, I'm going to come underneath policy, and underneath here, I'm going to go and I'm going to set up a access list. The name of the ACL is going to be, we'll set up iOS 13 block iNet. And I'm going to hit the enter key, and then underneath here, let me go ahead and scoot this up just a little bit so we can see it better. I'm going to go ahead and say sequence 1. I'm going to say match the source data. So we're going to create a source data prefix. Oh, the data prefix list. I need it. That's right. Let me go back one level and back one level here, and I want to create a lists, and I'm going to I have to create a data prefix list. That's right. I forgot about that. So data prefix list. Underneath here, we have to give it a name. We're going to call this iOS 13. We'll say loopback. Underneath here, we're going to say IP prefix, and the address is going to be 13.13.13.13/32. Okay, and I'm going to exit out of here, and I'm going to do a show config. And what I'm going to do is I'm going to create the same thing. I'll hit the up arrow. Let me go ahead and, since we're at lists, I'm going to hit the up arrow for data prefix lists. I'm going to create, this will be 14. And then the address we're going to use is going to be 14, 14, 14, and then 14. Like that, so show config. There we go. And then we're going to exit out once, hit the up arrow a couple times until we get back to here, and then iOS 15. And we'll make sure that we use the prefix of 15, 15, 15, 15. We're going to go ahead and exit out, show config. So now we have our data prefixes that have been created. I'm going to go ahead and exit out here. I'm going to create access list. The name of the ACL is going to be, we'll say, iOS. I don't want to create multiple sequence numbers here. Let's just go ahead and say the access list name in this case here. Let's tweak the name just a little bit so it's more obvious. So we'll type in spoke loopbacks, and underneath here we're going to say sequence 1. We're going to match on the source data prefix list, and we're going to call iOS 13, and then we're going to I don't know if you can call multiple. I don't think you can. I can try. We'll grab 14. That's what I thought. So we'll grab 13 out of the gate, and then I'm going to go ahead and say, we'll say sequence 2, we're going to go ahead and match. We'll match 14, and then we're going to go up to sequence 3, match, and then we're going to say 15. And then we're going to do a show config. Go ahead and exit out here. Show config. All right, so the option here is that we're saying access list do this. We're sequence 1 match router 13's loopback. We're going to go ahead and drop it. Same thing with sequence 2. Do this. We're going to match on router 14, drop it. And then we need to come in here and type in the default. We're going to come underneath here and say access list. And the name of the access list is spook loopbacks. Underneath here, we're going to say the default action will be to accept. Now you might say, okay, you've dropped everything else. Why are you accepting here? And the simple answer is, if we don't set a default action, what will end up happening is it'll just block everything else. Because basically it's going to be a deny, 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 right? And we don't want it to be all denies. Now I could be more specific. I could come in here, and actually let's do this a little bit differently. I can come in here, I could say default action is to drop, but if I come in here, I can create another list, for example. Let me come in here and type in lists, and underneath we'll create another data prefix list, right? And we'll give it a name. We'll come in and type in let's say RFC 1918 underscore 10net. Something like this, and we'll type in IP prefix will be 10.0.0.0/8. Okay, we'll get out of that, and then we'll go show config one more time, and then what we're going to do is the access list that we were creating. Let's actually back up one more level. We'll say that the access list of spoke loopbacks, we're going to come underneath here, we'll type in sequence 4. Underneath here we'll say match, and then the source data prefix that we're going to match on is going to be RFC 1918 10net, and we're going to exit out one level to that sequence, and then we're going to say action, and underneath here we'll say to why does it not say, we'll show config. I want to action, there we go, action accept. I don't know why it doesn't show it there. So show config, we can see now that the action is accept, so it should receive anything that's 10.0.0.0/8, anything, it should be good. So let me back out to here and do a show config, and let's do let's take a look at this in more detail. So we have the lists up here. We go underneath the policy process. We have our lists. These are basically going to be our prefix lists that we're going to create. So basically our ACL entries. We need to have something to match on. So we match on these particular prefixes right here. Then we create the access list itself, and the first sequence in the ACL is we drop, well actually let me go ahead and delete that. Let me go underneath access lists, and I'm going to say Control A, no that out, and then block iOS 13 block iNet. And so if we do a show config, we're going to delete that, so that will no longer be there. So just to clean this up, we have our lists where we're going to match on our traffic that we want to affect, and then we're going to say for 13, 14, and 15 we're going to drop, but on sequence 4 we're going to permit, but everything else is going to get dropped. So if we've got something coming from, for example, 172.16 or 192.168, it will also get dropped. So I'm going to go ahead and I should add in a counter, which I will go do real quick. I'll type in the access list name just so we can see that as it comes in. We'll do sequence 1, and we're going to say action is going to be count, and characters. We'll call this iOS 13 counter. We'll go up to sequence 2, and we're going to count, and then it'll be iOS 14 counter. And then sequence 3, action count, iOS 15 counter. And then we'll do sequence 4, action count, and then the name of this guy will be 10 net counter. So let's go ahead and exit out of that again. Show config one more time, just so we have something in there that we can match on. And there we go. So everything's supposed to have a counter. We're going to go ahead and I'm going to commit this config now. So now the config has been committed. Show run policy. Do show run policy. We can see that the config has been placed. And now we need to place it outbound. So we'll go underneath VPN1. We'll type in interface GE 0/2. And what I'm going to do is I'm going to type in access list. And the name of the access list is spook loopbacks. And we're going to specify outbound. Okay. We do a show config. We're going underneath the interface and we're going to apply it outbound. I'm going to go ahead and commit that config. So there we have it. So now if I go back over here to 13 and I try to do that ping again, ping 1.2.3.4, if we do a ping to that, that should work all day long. But if I ping from a source of loopback 0, that will fail. If I go back to VEdge1 and I do a show, and it is a, what's that command? I forgot off the top of my head. A show interface GE 0/2. One too many zeros there. And no, show what's that command? I remember. Let's see. Show policy. Show policy. Access list counters. That's right. So we can see traffic from that has been sent and back and forth. If we go to 14 and we try to do that again, we do a ping 1.2.3.4. That works all day long, but if we source it from loopback 0, the ping is dropped. Go back to VEdge1. We can see that the pings are being dropped, in fact. And back to 15, we'll ping 1.2.3.4. It works all day long, but if we source it from loopback 0, the ping is dropped. And there we go. So we've proven that the local data policies do work. And so we're a fair bit into this first video. So I'm going to go ahead. That's as far as I'm going to take this one. So we did a CLI base config. Now let's actually, I've got some more time. So what we'll do is I'm going to set one up to be we set this outbound on GE02, right? What I'm going to do is I'm going to create another access list and I'm going to apply that inbound on GE0/3. We'll do that so that R5 and R6 cannot telnet into 13, 14, or 15. So let's go ahead and knock that out real quick. So what I'm going to do is on 13, show run section line. Let's just do 13 for the simple fact that it's makes the job a little bit simpler to instead of having to configure it multiple times. Okay, so it's already there. So if I go to iOS 5, for example, and I do a show IP interface brief, and I ping 13.13.13.13. Okay, I can ping it. So that means I should be able to telnet to it. Go ahead and log in, Rob and Cisco. There I go. All right, now I'm going to create an ACL to block telnet. VEdge1, go back to global config under policy. Underneath here, I'm going to call I have to be a bit more specific though now because I need to match on more than just a prefix or more than just the source address. Now what I'm going to do is I don't care about the source, right? I don't care where the traffic is coming from. I care about where the traffic is going to. So an extended access list mentality, but I'm going to be specific to the transport, the protocol, and that type of stuff. That's what I want to care about now. So I'm going to go underneath here, and I'm going to call a list. Underneath here, I'm going to call it a, I'll still match on a data prefix list, right? I'm not going to change that up. And the prefix list name, I'm going to call this guy iOS 13 telnet. Underneath here, I'm going to say the IP prefix that I'm going to match on is going to be 13.13.13.13/32. You might say, well, why aren't you just calling it from the loopback? Well, because I want to make it specific to what it is I'm trying to accomplish. So I could technically reuse iOS 13. As a matter of fact, let's go ahead and do that. Let's actually not worry about trying to make it specific to because the prefix list itself is irrelevant, right? It's or you can do however you want, but as I'm sitting there looking at it, I was like, why do I want to have two prefix lists to call the exact same subnet? That doesn't make any sense. The ACL is where the logic changes. So let's go ahead and take care of that access list. Let me get ahead and get out of that. And then we're going to type in access list. And then the name of the ACL is going to be, we're going to say block iOS 13 telnet. And then underneath here, we're going to type in the sequence is going to be sequence 1. We're going to match. Underneath here, we're going to say the destination data prefix list of iOS 13 loopback. We're also going to match on the destination port of 23. Now we could say also destination, or I should say we could match on the protocol, and we'd have to know the protocol. Now the protocol and the port are two different things, right? So what's the protocol we're going to be using? Cue the Jeopardy theme music. Do, 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 do. So it's TCP, which is what protocol? Protocol 6. So we're going to have to throw protocol 6 in there, right? Go ahead and jump out of the way again. So we're going to match on protocol 6, so TCP transport to port 23. And then what we're going to do is we're going to do the action will be to be drop, right? And we're also going to say count. We're going to call this the telnet counter. Like that, get out of there, get out of there. And then what we're going to do underneath here, we're going to say the default action will be to accept. Because we're blocking telnet, but maybe we want to allow web, right? Or maybe we want to provide SNMP, or maybe we want to copy TFTP. Whatever you want to dream up is your call, right? But we want to have it set up to where we can filter the traffic based on our needs, right? So what I'm going to go do is I'm going to go show config. So just to recap what we did, we're matching on, we didn't create an extra AC list. We're calling an existing prefix list, and we're saying we want to match on the protocol or the destination port of 23, so we know it's telnet, and we're going to match on the protocol of TCP, and we're going to drop it, but we're also going to count the packets that are getting dropped. The default action is to accept every other type of traffic. I'm going to go ahead and I'm going to commit that config underneath the policy. You don't have to do that, but it's kind of a good idea to do so. VPN1 interface GE0/3, right? And then we're going to type in access list, and then the name of it's going to be block telnet to iOS 13, and then it's going to be inbound. Okay, so that's basically how that would get. So show config on that. We're going to go ahead and commit that config. Now we go back to iOS 5, and I hit the up arrow. It says that the telnet is unreachable. Right, we'll do it again just to prove it. Go back to here, show policy, access list counters for block telnet, and we have we have 2 packets being blocked. But if I go to here, and let's make sure that 13 is going to accept, let's go to IP HTTP server, and then the authentication will be local. Let's go ahead and give that a shot again. We're going to come over here and type in telnet to 13.13.13.13 to the port of 80. And that's open, right? We look over here at 13 and we do a show IP HTTP server connections. We have an active connection from 10.5.6.181 coming inbound. And if we look at VPN1 and we do that packet counter, we're not actually doing a counter for the default action. Well, we could. Let's go ahead and add that in real quick. Let's go back here, policy. We're going to show access lists. Well, let's actually do access lists. We're going to grab iOS 13. In the default action, we're going to accept, obviously, but underneath here we're going to put in a, oh, I guess we can't. That's fine, no big deal. Guess we can't count there. No worries. So we're good to go. The point being is we can get through there and everything is happy. So that's really the big win that we wanted to have. So we tested out inbound and outbound ACLs via the CLI with a localized data policy. So just to recap what we covered, we're gonna do a show policy. We're gonna have a lot in there. Show policy, or so show run policy, excuse me. We have a lot in here. So as you can see, it quickly becomes, we're not doing a lot, right? But it becomes a lot of information. We have what we're gonna be matching on here, right? We have our route policy for BGP routes, setting the loop or the local preference to be 1000. We have our block telnet to iOS 13. We have our spoke loopbacks where we're going to drop the traffic as it's going towards the ASA. So we have all that stuff going on. That's basically what I wanted to show you guys in this video. In the next video, we're going to do it via the vManage, and we're going to test out some of those same capabilities, but show you the configuration through vManage with the localized data policy. We'll have to create the lists, we'll have to create the data prefixes, we'll have to map them appropriately, and we'll have to call the ACL from the policy. Once that policy's been created, then we can push the policy down to the V edges that we want it to associate to, and then we can start doing, then we can tie the policy itself to the, once the policy is pushed to the V edge, then once all that's done, we can go underneath the template and call the access list and associate it to the interfaces in whatever direction we need to in order to affect the logic. It's a lot to remember. It is. I completely understand with that. I'm on board with those. That's basically what we're going to have to do. So it's it is what it is. So this will be, the next video will be a follow-on to this one, but we're already half an hour in and there's a lot to do. So thanks again stopping by and hanging out with me in this video, and I'll catch all of you guys in the next video.